Hi there, in this video we're going to discuss integration. So integration is the reverse of differentiation. So remember the basic rule of differentiation: multiply by the power and subtract 1 from the power. So that is what we used in order to work out dy over dx. However, with integration we'll have dy over dx and we're going in the reverse direction to calculate y. So if dy over dx is ax to the n, where a and n are constants, to calculate y, we need to integrate dy over dx with respect to x. So this elongated s sign means the integration sign, and dx means with respect to the x variable. So we know dy over dx is ax to the n, so if I replace dy by dx by ax to the n, we're going to integrate ax to the n with respect to x. And the result of the integration process will give us ax to the power n plus 1 divided by n plus 1 plus a c. C is what we call the integration constant, and we'll go through the idea of the integration constant later. However, don't learn the formula, learn the process, and the process of integration is we add 1 to the power and divide by the result of adding 1 to the power. So that is what I use to get ax to the power n plus 1 over n plus 1. So to get this, I added 1 to the power of n and divided by the result of adding 1 to the power of n. Now moving on, there's two types of integrals. There's the definite integral, and definite integrals are integrals with limits. So if capital F of x is the integral function of f of x, by integral function I mean the function that we get straight after integration. So if I have this definite integral, and b and a are what we call the upper and the lower limits of our integral. So after integration, if we have the integral function f of x, we write the limits a and b on the right hand side above and below a square bracket. So the upper limit goes on the top right hand side of that square bracket, the lower limit goes on the bottom right hand side of the square bracket. From there on, then replace the upper limit first in your integral function. So that is how I got capital F of b. Then it's always subtract, then replace the lower limit a in your integral function to give us capital F of a in this case. So that is how you would evaluate a definite integral. So that is the first type of integral. The second type is known as an indefinite integral. Indefinite integrals are basically integrals without limits. So if I'm integrating f of x with respect to x, and if we get the integral function capital F of x by adding 1 to the power and dividing by the result of adding 1 to the power, remember, plus a constant of integration in this case. So we only add a constant of integration whenever we integrate an integral without limits. So let's try some examples of definite integrals to start off with. So in example 1, question is to evaluate the following, and in part A, the integral of x with respect to x between limits 1 and 2. 1 is the lower limit, 2 is the upper limit. Let's integrate x with respect to x. So remember, if you have a definite integral, an integral with limits, start off by opening a square bracket. And remember the idea of integration. The idea is add 1 to the power. So currently the power is 1. So when I add 1 to the power, 1 plus 1 is 2. And we divide by the result of adding 1 to the power, which is also 2. Close the square bracket and put the limits of integration on the right hand side above and below that square bracket on the right. So the upper limit goes on the right hand side on the top, the lower limit goes on the right hand side on the bottom. So once you've done that, then replace your limits. First replace the upper limit into your integral function. So the upper limit is 2. So when I replace x by 2, I'll have 2 to the power 2 divided by 2. close bracket, minus in the middle, so we always minus. Then replace your x in your integral function by the lower limit, which is 1. So when I replace by the lower limit 1, I'll get 1 to the power 2 divided by 2. So the rest is now calculation. So 2 to the power 2 is 4. 4 divided by 2 is 2, minus 1 squared over 2 is 1 over 2 or half. 2 minus half, 3 over 2. So this should be the solution to part A. So back to the screenshot. So we have another example. So here's part B. Part B is to integrate 2 with respect to x between the limits 1 and 3. So let's have a go at this one. Back to the paper and pen. So we're integrating 2 with respect to x between the limits 1 and 3. Now with 2, I could write that as 2x to the power 0, as x to the power 0 is 1, remember, between limits 1 and 3 in this case. So remember the idea of integration, add 1 to the power and divide by the result of adding 1 to the power. Since I've got a definite integral, an integral with limits, let me open up a square bracket. So if I add 1 to the power, 0 plus 1 is 1, divided by the result of adding 1 to the power, which is also 1. Close that square bracket, and we write our limits on the right hand side, top limit, or the upper limit rather, right hand side on the top, lower limit, right hand side on the bottom. So from here on, let's replace the limits. First, replace the upper limit into your integral function. So when I replace the upper limit, I'll get 2 into x, which is 3. Close the bracket, always minus in the middle. Then replace your lower limit being 1. So when I replace 1 in the integral function, I'll get 2 into x, which is 1. So let's simplify this. 2 into 3, which is 6, minus 2 into 1, which is 2, 6 minus 2, 4. So this should be the solution to part B. So part C, integration between limits 1 and 4, x squared plus 1 over root x with respect to x. So back to the paper and pen. So here's the question for part C. So before we integrate, let's write both of these terms in the form of ax to the power of n. So let me rewrite this. So the limits are 1 and 4. X squared, that's already in the form ax to the power of n, plus 1 over root x is the same as x to the power minus half. So remember, root of x is the same as x to the power half. But if I have 1 over root of x, bringing the x to the half upwards will change the sign of the power. So with this being said, let's integrate. So since I've got a definite integral, let me introduce a square bracket. So let me open up a square bracket. So for the first term, if I add 1 to the power, 2 plus 1 is 3, divide by the result of adding 1 to the power, which is 3, plus in the middle. Let's integrate the second term. So when I add 1 to the power, minus half plus 1 is plus half, divide by plus half as well. Let's close that square bracket, and let's include the limits. So the upper limit is 4, so write that over here. Lower limit is 1, write that over here. So what needs to be done is, let's substitute in the limits. But before I substitute in the limits, let me simplify this integral function. So let's simplify this. So x cubed over 3 plus 1 over half is the same as 2, x to the power half, between the limits 4 and 1. Now let's replace the limits. So upper limit needs to be replaced first. So upper limit 4, so I'll have 4 to the power 3 over 3 plus 2 into 4 to the power half. Minus in the middle as always. Then replace the lower limit being 1. So when we do that, I'll have x, which is 1 to the power 3 over 3 plus 2 into x, which is 1 to the power half. When you calculate this, you should have an answer of 23. So that should be the final answer to part C. Right, so I have another example. So back to the screenshot. So part D, we need to integrate between limits 1 and 4 root x plus 1 cubed. So let's integrate root x plus 1 cubed between limits 1 and 4. So back to the paper and pen. So here is the question. We need to integrate root x plus 1 cubed. So first of all, let me expand the integrand. So as a side calculation, let me expand the root x plus 1 cubed. So to expand root x plus 1 cubed, I'm going to be using this identity. So I'm going to use the identity for a plus b cubed. And a plus b cubed has the form a cubed plus 3a squared b plus 3ab squared plus b cubed. So by comparison, we note that a is root x and b is 1. So let me make a note of that. So a is root x, b is 1. So if I replace the a and b into the identity, we're going to have a, which is root x, plus b, which is 1, cubed, and that is the same as a cubed. A is root x, so it's a root x cubed, plus the 3 into a, which is root x, don't forget the square, times b, which is 1, plus the 3 into a, which is root x, multiplied by b, which is 1, don't forget the square, plus, and b, which is 1 to the power of 3. So this is what you should have upon substitution of a and b into this identity. So let's simplify further. So root x, so remember root x is the same as x to the power half, and x to the power half to the power 3 is the same as x to the power 3 over 2. So remember this concept in indices, x to the power a to the power b, that is the same as x to the power ab. So I'm using this very result to calculate x to the half to the power 3. So let's continue. So plus root x squared is x, x times 1 times 3 is 3x, plus 3 times root x, or x to the half, is 3x to the half, times 1 is 3x to the power half, plus, and 1 cubed is 1. So this is what you should have when you expand the integrand. So let's use this in order to help us with this integral. So now we're integrating between limits 1 and 4, x to the power 3 over 2 plus 3x plus 3x to the half plus the 1. So let's integrate that with respect to x. So since we have a definite integral, let's use a square bracket. So let's open up a square bracket. And remember the process of integration, add 1 to the power and divide by the result of adding 1 to the power. So when I integrate x to the power 3 over 2, when I add 1 to the power, 3 over 2 plus 1 is 5 over 2, divided by 5 over 2 as well, plus, so a plus, when I integrate 3x, when I add 1 to the power, I'll get 3x to the power 2, divided by 2, plus, so plus, when I integrate 3x to the half, when I add 1 to half, half plus 1 is 3 over 2, so I'll get 3x to the power 3 over 2 divided by 3 over 2, plus again, and when I integrate 1, it's 1x. Let's close that square bracket. And remember, the limits go on the right hand side of the bracket. So the upper limit appears here, the lower limit appears here. So before we substitute in the limits, let's tidy this up. So in this case, 1 over 5 over 2 is the same as 2 over 5, x to the power 5 over 2, plus the 3x squared divided by 2, plus 3 divided by 3 over 2 is 2, and I'll have 2x to the power 3 over 2 plus this x. Let's close that square bracket and write the limits on the right hand side still. And now we can replace the limits in to our integral function. So first let's replace the upper limit. So if I replace x over here by the upper limit 4, I'm going to have 2 over 5 x replaced by 4 to the power 5 over 2 plus 3 over 2 x replaced by 4 to the power of 2 plus the 2 x over here replaced by 4 again to the power 3 over 2 plus x, which is 4. Let's close that square bracket. Minus in the middle. And now let's replace the x's over here by the lower limit being 1. So if I replace by 1, I'll have 2 over 5 x replaced by 1 now to the power 5 over 2 plus 3 over 2 x replaced by 1, so 1 squared, plus, and let me continue here, 2 into x replaced by 1, so 1 to the power 3 over 2 plus x, which is replaced by 1. And when you calculate the final solution, you should have as a fraction 519 over 10. So this should be the final solution to part D. So I have some more examples. So back to the screenshot. Now